What's up, guys? Nate Morris, MasterLSAT.com. In this video, we are going to do the third logic game from PrepTest 77, the office game, which was a very, very tricky game for a lot of people. We are going to try to do it in under 10 minutes. So I guess as I'm speaking, you can see the length of the video and you'll know whether I was successful in doing that or not. But at any rate, let's take a look at PrepTest 77, questions 13 through 17. So we have 4 employees, J, L, P, and T, and they're going in order. They're selecting offices. So essentially, it's a sequencing game, right? We're putting 4 things in order. And also, each of them gets a secondary variable, whichever office they pick. They each get associated with a lowercase letter. If you've done logic games with me before, you know that whenever there's a secondary variable, I like to show it as a lowercase letter. And in a sequencing game, we're going to put the uppercase letter on the top of the line and the lowercase letter on the bottom of the line. So in other words, the order that the uppercase letters go is going to be up here. Right? I'm just making up a random order, JLPT. And then whichever office they pick is going to go underneath. Again, I'm just doing this randomly just to show you what it's going to look like as we map out the scenarios. But as it so happens, this game is not going to require us to draw out a lot of stuff. A lot of these questions are just going to be thinking questions, and we're going to be able to look at them and kind of figure them out using our reasoning skills. So that's why it's very important on this game not to sort of panic and freak out because it's a little bit of a different game than a lot of other games you've seen, but always keep your mind open, keep using your analytical reasoning skills as you're working through the questions, and you should be able to do just fine. You'll find a lot of these questions are a lot easier than you may have thought. So what do we have going on here? We have 4 employees are picking from 4 offices, and the order in which they select from first to fourth is decided randomly. So essentially, we have JLPT going in order, in some random order, and then each one of them picks an office, and we see what their preferences are. Now, normally I wouldn't copy this out because it's already on the page if you're taking this test, but just for our convenience, I wrote out all the preferences on the page in front of us so that we can be consulting that. So essentially, it says each employee picks an office that hasn't been selected previously, and each employee picks one office, and then here's the number 1 main rule of the game. Each employee selects the office that they rank highest among whatever offices are available. So that means that whoever goes first is going to pick whatever their first choice is, right? Whoever goes second is going to pick whatever their best choice is that's still available. So it might not be their second choice. It might be their first choice, right? So once we understand how this game works, we'll be able to fly through the questions, right? The uppercase letters can go in any order whatsoever. It doesn't matter. You can put them in any order and it's always going to work. Whatever order they go in, all you have to do is consult the list of preferences to know what offices each person is going to pick. So let's say, for example, J went first. Let's say J went first. We know J's first choice here is Y. So therefore, J's going to pick Y, right? Let's say then L went second. Well, we would look at L, and L's first choice is X, which has not been taken yet. So therefore, L will get lucky. L will also get its first choice. And then let's say T went third. Well, T's first choice is X, which is not available because L took X, right? Second choice is Y, which is also not available. So therefore, T would get left with Z. And then whoever goes last is kind of just going to have to pick whatever's missing, whatever hasn't been picked yet, which in this case is W. So as long as we understand exactly how the game works, the key here is that whoever goes first always gets their first choice, right? We know that, right? So let me just make note of that. Whoever gets first always is going to get their first choice. Whoever goes second might get their first choice, or if their first choice is taken, then they'll take their second choice. But they'll never take their third choice. That wouldn't make any sense, right? Because at best, they'll get their first choice. At worst, they'll get their second choice. If we go down the line, whoever goes third, maybe they'll get lucky enough to get their first choice, or maybe their second choice, or maybe they'll be stuck with their third choice. But they're definitely not going to get their fourth choice because there's always going to be 2 offices left. So why would they take their fourth choice, right? And then whoever goes fourth, in theory, could get either first, second, or third, or if they're unlucky, they'll get their fourth choice. Now, the way that the preferences line up, it's actually impossible that, for example, that the fourth person gets their first choice because the first choices are all Y's and X's, and those are definitely, therefore, going to be taken by that point in time. But I just want to illustrate the basic logical principle of how this game works. So with that out of the way, let's go ahead and look at the questions. Number 13, which of the following is a possible matching of the employees with the offices they select? Now, the important part of this question that nobody noticed when they read the question is that it does not say in the order in which they select them. So this doesn't mean Jackson goes first and picks W or Z or X or Y, and then Larrabee goes second, because if that were the case, none of these work, right? You'd have to start with D and E because Jackson picks Y in those, but then neither of those make sense because if Larrabee went second, Larrabee would pick X. Larrabee wouldn't pick W, Larrabee wouldn't pick Z, so neither of those work. So a lot of people give up when they get to that point. They're like, wow, I must totally misunderstand this game. None of these answers are working. But the key is you have to read the question more carefully. It doesn't say in the order in which they select them, which means we have to go through each answer choice and figure out what the order could have been. So let's start with A. Let's start with A on number 13. Who could have gone first in A? Well, not Jackson, because Jackson didn't pick his first choice, if that's the case. Larrabee, no, because Larrabee's first choice is X. Paulson, no, because Paulson's first choice is Y, and in A, Paulson picks X. Torillo, Z, no, that's not its first choice. So nobody could have gone first in A, and therefore A does not work. So let's go ahead and try B. B, did someone get their first choice in B? Could someone have gone first? And the answer is yes. If you look through these, you'll find that Larrabee picks X in B, which means Larrabee could have gone first. So we already have a possible answer here. Who could have gone second? Let's see. Jackson, if Jackson went second, would Jackson pick Z? No, Jackson would have picked Y. If Paulson went second, would Paulson have picked W? No, because that's Paulson's last choice. If Torillo went second, then yes, Torillo would have picked Y because Torillo would have liked to pick X, but X is no longer available. Great. So we're on a roll here with B. Who could have gone third? We crossed L and T off. So Jackson, if Jackson goes third, would Jackson pick Z? The answer is yes, because Jackson's first two choices are unavailable and Z is Jackson's third choice. And now we know that we are done the question because whoever goes last is always just going to pick whatever's left. So we don't even have to look at the preferences. We know that whether it's Paulson's first, second, third, or fourth choice, it happens to be Paulson's fourth choice, but either way, Paulson's going to be stuck with W no matter what. So therefore, B is our answer. That is going to be the answer number 13. Let's look at number 14. Which of the following must be true? Now, normally we would have to test these out. We'd have to test them out to see which one must be true. But in this case, you should notice that they're all general logical statements. And therefore, let's see if we can just use our mind and look for an obvious answer, right? A, does it make sense that at most one person gets their first choice? No, why would that be the case? What if J went first and L went second? Then they both get their first choice, right? So why would A have to be true? B, does it make sense that at most one person gets their second choice? I don't see any logical reason why that would be the case. So let's keep reading. Let's look for an obvious answer. C, does it make sense that at least one person gets their first choice? Yes, that's the principle we've been using to solve number 13, right? So if you got number 13 right, there's no way that you should miss number 14 because in order to get number 13 right, you have to know that. You have to realize that, oh yeah, whoever goes first has to get their first choice. Maybe whoever goes second also gets their first choice. Maybe whoever goes third, but at least one person, whoever goes first, must get their first choice, which means the answer to number 14 is going to be C. Let's look at 15. 15 says, which of the following could be true? Again, they're all general logical statements, so let's see if we can find one that makes sense or at least cross off some of the obvious ones. So let's see. There seems to be three that we can cross off pretty quickly. So B, exactly two people get their fourth choice. Why would two people get their fourth choice? If we're looking over here, we see that only maybe the last person, if they're unlucky, is going to be left with their fourth choice. But whoever goes third, they're never going to get their fourth choice because why would they? There's always going to be two things left. So maybe if they're unlucky, if they're super unlucky, it'll be their third choice, or maybe it'll be their second or first choice. But why would they ever take their last choice? That doesn't make sense. So at most one person is going to get their fourth choice, which means B is impossible. By the same token, D and E are also impossible. D says three people get their third choice. As we can see, at most two people get their third choice because whoever goes second, why would they ever take their third choice? There's always going to be three things left. So maybe they'll get their first choice or maybe their second choice, but it would never be their third choice. And then E, certainly if two people can't get their fourth choice, then certainly E is impossible also. Why would three people be able to get their fourth choice? That wouldn't make any sense. So we're left with A and C, and neither one of them is obvious. A says two people get their third choice, which logically seems like possible, right? C says three people get their second choice, which also logically seems possible, but that seems a little trickier. Three people all getting one choice, whether it's second, third, or fourth, or first, seems harder than A. So let's investigate. Let's drill down on that. If we look at the actual preferences that they have, three people getting their second choice. Well, what are the second choices? We see the second choices are X, Z, and Y. Now, where would those three people have to go to get their second choice? Well, whoever goes first gets their first choice. And therein lies the problem with C, because whoever goes first is going to have to therefore pick W, right? Because if three people get their second choices, the three second choices would have to be X, Z, and Y, because those are the three things that are second choices, which means whoever goes first would have had to pick W. That's impossible because W is nobody's first choice, which means C doesn't work, which means without testing anything out, we know that A is the answer. We're about to hit the 10-minute mark, but let's keep going. Let's see if we can do it under certainly under 15 minutes, but hopefully even less than that. Let's look at number 16. If Paulson picks W, so this is the first time we actually have to draw something out. If Paulson picks W, we're going to make the if true. Let's say Paulson picked W. Well, Paulson, if we look at Paulson's choices, W is Paulson's last choice, which means the only way Paulson could ever possibly pick W would be if Paulson went last. Otherwise, it wouldn't make any sense, right? So we know that. Now, other than that, we don't know anything because the other three letters could conceivably go in any order, and whatever order they go in will dictate what office they pick. So therefore, let's go ahead and test the answers out. Which of the following could be true? So anybody who looks at this question will obviously, as long as you remember that there's no gun to your head saying you have to go in alphabetical order A, B, C, D, E, you'll realize, hey, wait a second, D and E seem a heck of a lot less intimidating than A, B, and C. Why don't we start with those? Why don't we just test out D and E, test the easy ones out first? And that generally seems to be the smart way to do this question. So if we go to D, Jackson picks X. Well, let's look at the preferences. X is Jackson's second choice, which means someone would have to go before Jackson and pick Y. Otherwise, Jackson would never pick X if Y is available, right? But the problem is if L goes before Jackson, L will take X, which means Jackson can't take X. If T goes before Jackson, same thing. So P would have to go before Jackson. In order for Jackson to pick X, P would have to go first and pick Y and then Jackson. But the problem is P's going last here. So D is not going to work. What about E? Could Larrabee pick Z? Well, Z is Larrabee's second choice. So all we need to make sure of is that somebody picks X. Somebody goes first and picks X. Torillo, that's easy. We can just put Torillo first. Torillo gets his first choice. And then if Larrabee goes second, then great. And then Larrabee will get Z because that's Larrabee's second choice, right? And then who's missing? We have T, L, and P, so we're missing J. And look at that. J gets lucky. J gets J's first choice, which is a Y. And this works. This follows all the rules, which means the answer would have to be E for number 16. It leaves us with one question left. Number 17, which of the following must be true? So let's go through these one at a time and try to make them false. That's how you test out whether something must be true, is you try to make it false. So number 17A, Jackson doesn't select office X. So in order to make that false, we're going to try to make Jackson pick X. Now, that seems pretty easy because X is Jackson's second choice. All we have to do is make sure someone picks Y before Jackson goes, which means that could be P could go first and pick Y. Jackson could go second and pick X. We don't even have to finish that off. Whatever we do, it's going to work, and therefore the answer is not A. We just made A false. What about B? Does Larrabee have to not pick W? Can we make Larrabee pick W? Now, let's test this out. Let's try to make sure that we can find a way for Larrabee to pick W. So what's unique about W is that W is everyone's last choice except for Larrabee. If you notice that, then you'll save a lot of time on this because a lot of people spend a ton of time trying to test B out. But if you notice this shortcut, you'll realize, wait a second, everybody else, W is their last choice, which means all you have to do is put Larrabee last and they'll all leave W for Larrabee. It doesn't matter what order you go in. Because whatever order you go in, none of the other three are going to pick W, which means Larrabee, by definition, is therefore going to be stuck with W. And we can prove that just by making up a random order. J, P, T. J would pick Y. Paulson would therefore pick Z. T is going to get his first choice, which is X. And then Larrabee, like we said, is left with W. That would have worked no matter what order we did. C. Larrabee picking Z. Well, look at that. We already did that in number 16, so we know that's possible. We know that's not the answer. We know it doesn't have to be true that Larrabee doesn't pick Z. D, Torillo doesn't pick X. We also did that. And by the way, that's incredibly easy to see that that's possible because X is Torillo's first choice. That leaves us with E. So we're done. We're done the game. We know that the answer must be E. But that being said, let's just test it out just to see why E has to be true. So E says Paulson doesn't have to pick X. Or at least, I'm sorry, E says Paulson cannot pick X. It must be true that Paulson doesn't pick X. Now, let's try to make that false. Let's try to make Paulson pick X. Now, if we look at the preferences, X is Paulson's third choice, which means Y and Z have to be taken previous to whenever Paulson goes in order for that to ever be the case. The problem is, that means two people have to go before Paulson, and those two people would have to pick Y and Z. The problem is that any two people that go before Paulson, whether it's J, L, T, any two of those letters, one of them is going to pick X because L would pick X no matter what, and T would pick X, right? That's their first choice. So there's no way to put two letters before Paulson such that they will leave X for Paulson, right? because whichever two letters are, one of them is going to pick X, and X is going to be off the table. So there's no way for Paulson to pick X. That's why E is the answer. Anyway, hopefully we didn't go too quickly. Maybe I'll do another longer video explaining some of the logic of what we talked about in this game in the future. But at any rate, I just wanted to, I guess we did it in under 15 minutes. We completed this game, very tricky game. Let me know in the comments if you have any ideas or any difficulty with any of these questions that you want to share. And if there's any other games that you'd like me to kind of do a speed run through, let me know. And we'll see you in the next video. And if you want to get way more tutorial videos of official LSAT questions, thousands of tutorial videos, head over to masterlsat.com. Thanks a lot and have a wonderful day.